Practice drawing position versus time graphs. Here's our first one. Car A is 100 meters behind car B and traveling in the same direction and at the same speed. What are the features I'm focusing on? Car A is behind car B, traveling in the same direction. So same direction, same speed. And it doesn't tell us where, so I'm going to pick anywhere. So I'm just going to say, because I don't want to fall in love with the origin, although I really do like it, this is going to be A, and this is going to be B. Okay, I wouldn't normally put the label there, but I did this time. Okay, same speed, same direction. So I'm going to give B a positive slope. That much slope. Okay, well now I'm committed because I've got to give A exactly the same slope. Why exactly the same slope? Because slope on a position versus time graph is velocity. So same slope. So this is it. Always good to go back and double check. Is A behind B? Are they going in the same direction? Are they going at the same speed? Yes. Next example, cars A and B are initially 100 meters apart. Car B catches up to and passes car A. So we know car B must start up behind car A. And if it catches up to, it's going faster. So let's get our initial positions. B has to start behind. I'll go ahead and put B at the origin. I guess I do like the origin. And A must be ahead initially, so there we go. So let's get A going. A is moving in the positive direction. We could have made this all negative if we wanted to. There's nothing in the scenario that says we can't be going in the positive direction, but here we go. So A is going to be going, I don't want to make it too steep. It's too steep rather. There's A. Moving along. Now B starts out behind and passes. So B has to be going faster, so I need a steeper slope. There we go. There's B. Now, notice that, is this where they pass? Not really. Where they pass is actually, should be using black. Where they pass, it's just like if you were trying to find your values on a Mathland graph, okay? This would be like the x-coordinate, x-axis in math and the y-axis in math. And you say, what are the values? Well, this is the where the passing occurs, and this is the when passing occurs. Double check. I think it looks good. Next scenario, 3 bicyclists start a race together. They all pass the starting line at the same time when the race starts. Bicyclist A travels at 30 kilometers per hour, B is at 20 kilometers per hour, C is at 10 kilometers. So I noticed, okay, A is going 3 times as fast as C, B is going twice as fast as C. That's going to come into my slope. Okay, they all start at the same place. I still love the origin, but I'm going to skip the origin because I don't want you to fall in love with the origin like I do. Okay, there's A. They're all going to start the same. So, no, this is, A is purple. Well, let's do C. Okay, we're going to start with the most gradual one. So we're going to have C going pretty shallow. That's C. You can put it at the origin if you want. And then A is going to be going, A is going to be going twice that steep. Now, why did I do that again? I wish I hadn't, but oh well. Okay, well, for reference, okay, wow, it would have been easier putting at the origin. Okay, it's about twice as steep. We're not going to get out a protractor and measure. It's steeper, and it's significantly steeper. Now, A is going the fastest of all, so if that's C, B, A-ish. Okay, there we go. Let's see, start at the same place. C is slowest, most shallow, then steeper, and then steepest. I think it's good. Don't have to start at the origin. If I had to do this over again, I probably would have, because this time axis would have been a nice reference line. 2 runners on a sidewalk are moving towards each other at the same speed. So towards each other, same speed. So opposites, one's plus, one's minus, but the same magnitude steepness. The runners pass each other at the origin of our frame of reference. Okay, a lot of you are going to want to say, well, they pass right here because this is the origin of my graph, but that's not how it works. Okay, here's why. Well, because they can't. This is the position axis, you could say, or represents the position, and this is time. At the beginning, they can't be. So I'm going to say, here's one runner. I'll call it 1 and 2. And here's the other runner. So this guy's going to be number 2, and this guy's going to be number 1. Right? They're moving towards each other at the beginning. So at t equals 0, they've got to be some distance apart. So if this is the origin, there's one runner, there's the other runner. They're moving towards each other. They're going to cross at the origin, but not at t equals 0. It's at some t equals later time. So let's just see what happens. Purple. All right, so number 1, a certain steepness going negative, heading towards the origin. Remember, this graph, this is the time. So what does this graph tell us? This graph is telling me that as time goes on, this person's position is getting closer to the origin. Okay, I need symmetry. I need to have the same steepness because they do pass at the origin. Yes, and this is passing at the origin. Remember, this axis tells you when, and this axis, but you're going to trace it back. So this is where? So this is, x passing, x passing is occurring. It is occurring at the origin, but not at t equals 0, at t sometime later. So you've got to think about, don't think that the origin of graph is exactly the same as the origin of your frame of reference. Your frame of reference is only the only the x-axis. In this one, we're given a diagram. It's essentially like a meaningful sketch, except fancier because it actually shows the cars. And we're supposed to make a position versus time graph. So the first thing I want to do is I want to look at the x-axis, the x-axis of our frame of reference, because this is positive. So the first thing I noted, well, one of the things I noticed is, they're going to be going negative, so negative slopes. Then, so it gets me ready. I think you're going to have stuff going down. And then I say, where are they? A starts at 120 and B starts further away and about half again as far away. So we're going to start A. Let's see, color A has been purple so far. So if this is A, I'm just going to pick some, that's where A is going to start. And then B is going to start about half again as far. So something there. Again, we're not looking for like measuring this precisely, but it should be relatively consistent. Now what do I see? I see B is going much faster than A, 3 times as fast. So I'm going to start drawing I'm going to make my slope for A pretty shallow, so because I know that B's got to be 3 times steeper. So A is going at some rate in the negative direction, so negative slope. I wasn't aiming for the arrow, and I didn't mean to squiggle at the end, so there's A. So let's just forget that part. Okay, now B, 3 times as steep. So that's A's. So 1, 2, 3, a lot steeper. Okay, just a lot steeper. There we go. Okay, now where does this occur exactly? Well, I don't want to get into, let's get into the numbers. I don't want to talk about numbers. I want to talk about qualitative. Next graph, another picture, another meaningful sketch. Okay, what do we got? We got objects C and D. First thing I do is I notice the orientation of which way is positive, which is to our left. And then, got 2 going opposite direction. So D is actually going in the positive direction. So D is going to have like a positive slope, and C is going in the negative direction. So its line is going to be down. Where do they start? C starts at the origin. I'm going to make C green. So C is going to start there, and D, I like purple. So D is going to start negative. So D is negative going positive. Negative start and going in the positive direction. C starts at the origin but going negative. Let's do C first. All right, C is 20 meters per second. D is 30. So just pick some reasonable. Don't want to go super crazy. Just something, because I know D has to be steeper. Ooh, bold. That's C. Okay, there's C. Now we're going to do D. Got to be, half again is steep. That's actually fairly steep, so I mean, I got to be, all right, so that's about this. Oh, well, there you go. That's the same, and now a little bit half again-ish. So there we go. Should be close. It is. Probably should have made it a little steeper. Well, I'm going to let it go. Bothered me a little bit. Probably should have gone like that if I had to do it over again. Double check. C's at the origin. C's going negative. D starts in negative territory going positive. Wish I'd made it a little steeper, but I got to let it go. Last graph has no words, no diagrams. It's all based on equations, and we can still, our line should be consistent with the information in these equations. All right, let's do, A is purple, I think. Okay, but I don't want to do A, I want to do C. So C is going to be green because I see, oh, look, it's kind of easy. There's no T. What does that mean? That means no matter what time it is, C is always going to be at -5. I also, since I've done this before, I realized, okay, that's +10. So I don't want to go crazy down here because A is going to have to be further away. But let's get started. That's a reasonable amount. All right, so there it is. Flat line, 0 slope, 0 motion. It's always going to be at -5. C's position is independent of time. That's what a flat line means. It doesn't matter. Every time I look, C is at the same position and negative. Okay, what's B doing? B starts at the origin. I know that because this is where it would be if there was plus something. There's nothing, so B has to start at the origin. It's going to have some negative slope. It's qualitative, so we don't have a way. So just some negative slope. So there is B. Now, A is going to start at +10. If this is -5, -5, then it should be twice as far away. So something pretty far up there. And what's it going to be doing? It's going to be going positive and the same magnitude, same speed, right? Different direction, same speed. That means the same magnitude slope. So I'm going to just wing it here. I want to make, what? Oh yeah, we're doing A. Sorry, A is purple. Okay, so basically same amount of steepness, just gonna try to wing it. Not bad. We're not gonna measure with a protractor. Okay, let's double check. C starts at negative territory and is not moving. B starts at the origin and has negative slope because negative velocity. A starts twice as far on the positive side as C does, and it's got the same amount of steepness, but obviously it's going to be positive slope instead of negative. All right, these are the motion graphs.